Alright, so for those of you that needed a little bit of extra help when factoring, I'm going to go through a bunch of ways to factor, and I hope this is helpful. To start off, we're going to look at this first type of problem, and this is a factor by grouping problem. I am starting with this for a very specific reason, because we're actually going to use grouping again. So grouping is an interesting one. A lot of times you can identify it because there are an even amount of terms. A lot of times it tends to be 4 terms. So what we're going to do is we're actually going to factor the GCF. And so just to start off, this one is by grouping. We're going to factor the GCF of the first 2 terms. And what they have in common is p cubed. And if I factor out the p cubed, I have a p squared. And then I have a minus 5. And then in the second set of terms, now what you want ultimately to happen is that this term, p squared minus 5, is the factor of the last 2 terms. So a lot of times you'll see me write it down, and then I divide both terms by the same number. And if I can divide them both by the same number, in this case positive 8, and it creates 8p squared minus 40, then that means that this is factorable by grouping. Now the next thing is you're going to do the GCF again. So the GCF now of the 2 terms, term 1, term 2, is that p squared minus 5. So what we do in this case is we actually factor out the p squared minus 5. And now that it's factored out, the terms that are left, well, if we divide the p squared minus 5 from the first term, that's this part, we'd have a p cubed. If we have the p squared minus 5 factor from the second term, we would have a positive 8. So now what we have are our 2 factors. We're actually going to use grouping again, so I wanted to show that. A second example is just the simple basic factoring. Most of you were able to do this without a problem. You're looking for 2 numbers that multiply to 63 but are going to add to negative 16. I hope that you go in a systematic order so that you know which factors you checked. In this case, this symbol right here with the constant helps to tell you the 2 factors, whether you'll add them or you'll subtract them. And because it's an addition, I want 2 numbers that are going to add to 63. And those 2 numbers would be, multiply to 63, but add to negative 16. So 7 times 9 gives me 63. For them to add up to negative 16, they would both have to be negative. And now that I know that, I get x minus 7 times x minus 9. All right. Next, now we have a coefficient. So I am going to show this specific problem 2 different ways. To start off, we are going to use grouping because we just looked at it. So grouping method is interesting because it simplifies the problem a bit for you. You're going to multiply the a coefficient and the c, and you get negative 140. You're going to look for 2 numbers that multiply to negative 140 but add up to negative 31. So this minus sign says the 2 factors that I picked, you're just going to subtract them. In this case, 35 times 4 gives me 140. If I subtract them, that would give me 31. And so you figure out which term has to be negative because they have to multiply to negative 140. And if I want them to add up to negative 31, then I'm going to need them to have one of them be negative, one of them positive, and the larger one has to be negative. Now here's the part that makes the problem grouping. You're going to start off by writing the coefficient, not the coefficient, this leading term here, the 7x squared. You're going to copy down the terms that sum up to negative 31x, and what you'll do is you'll take the negative 35 and put an x. You're going to add up 4 x's. Together they'll make that negative 31x that was the beginning term, and then at the end you're going to add that negative 20. So what you've really done is just rewrite the same thing exactly. It's exactly the same, it's just written with 4 terms instead of 3 terms. And then you go grouping. So grouping says we are going to break the function there. The expression, we're going to factor out the common term. In this case, 7x is the common term. If I divide 7x for the first term, we get an x left over. 7x from the second term, I get a negative 5. If it's factored by grouping, then this should be the factor. So now I'm going to look at the values, and I'm going to say, is there a value that I can divide 4x minus 20 by so that I can have x minus 5 be the remaining factor? And that would be positive 4. How do I know that? Because 4x minus 20. So now that I've done that, we know that the common term, GCF one more time. So the GCF in this case is x minus 5. Therefore, the factor that's left over, 7x plus 4. So the way you think about it is if you divide this first entire term by x minus 5, you'd have remaining the 7x. If you divide this whole entire second term by x minus 5, you'd have remaining the positive 4. So in a sense, the second factor causes you to have those remaining values after you divide out the greatest common factor. Alright, so same exact problem, guess and check. A lot of you won't like this way. It is a method that forces you to double check if your answer's right, which is actually the reason why I like it. So for this method, you take the factors of 7, you take the factors of 20, and once you get good at it, you don't need to write them all down. And you are essentially pairing up values so that you subtract the products to make negative 31. So, essentially what happens is, mentally you are taking one of these numbers and pairing them up with a number. So 1 times 20 is 20. 7 times 1 is 7. Subtract them because of this minus sign, and I get 13. So 13 is not 31, so that can't be the answer. So then we go back and we try another set. We're trying to get 31. Well, we can try 1 and 4. 7 times 5. 1 times 4 is 4. 7 times 5 is 35. Subtract them and you get 31. So those are our factors. So the question is, how do you build the factors? So if you really understand how to multiply out binomials, it helps to understand why this works. The 1 and the 7 have to be the x terms of your factors. The 4 and the 5 are going to be the constant terms of your factors, but the way that they have to be laid out is that the x has to partner with the back constant, and this 7x must partner with the first term's constant. And how do we know who gets partnered? It's literally following the original lines you did. So the 1 right here got partnered with the 4. So I'm going to take the 1 and partner him right here with the 4. And then the 7 was partnered with the 5 to make 35. So the 7 is partnered with the 5 right here. How do I know which one's positive, which one's negative? Well, we want negative 31, so I need the 35 to be negative, which is why this would be negative, and this would be positive. Negative 5 times positive 7x would get me the negative 35 that I needed. So those are those factors. Either way will work. I really don't mind which way you do it. All right, next guy. So this is given just so you see that there are going to be GCFs. So in this case, every single term has an n. So that means at most I can take out an n squared. 28, 16, 80, they are all divisible by 4. So 4. So 7n squared is what's remaining after I divide out n squared from the first term. The next term would be 4n. And then the last term would be minus 20. Now I'm going to double check 7, 4, and 20. I can't take out another GCF, so I did get the greatest common factor in front. So next, we got a factor again. So I will again do this both ways. First of all, I'll do by grouping. So 7 times negative 20, negative 140. I need two numbers that multiply to negative 140, but are going to add up to positive 4n. Let's see. So those values would be 14 and negative 10. So, factor by grouping, don't forget about your GCF in front. I'm just going to put a bracket so I don't forget about it. There we go. So, in the front I have 7n squared. Next I have 14n. That came from here. Next I have 10n. That came from here. And lastly I have the minus 20, which was the original constant. Next I'm going to factor by grouping, which means break this in half right here. And don't forget your 4n squared. My greatest common factor for my first two terms would be 7n. I have left over an n plus 2. My greatest common factor for the next term would have been 10, but because I want a positive n plus 2, I'm going to have to factor out a negative 10. And we double check that yes, that makes negative 10n minus 20. So I'm pretty much done. Last step. My 4n squared is one of my factors. Don't forget about that guy. And then the common term is a factor. n plus 2. And then the remaining pieces, the 7n minus 10, creates the other factor. And remember, that's because we divided the n plus 2 from each term, and that's what's remaining. That's method 1. Here's method 2. I'm going to take the first step, which is the same for both sides, factor out the GCF. Always makes it easier. Next step, I'm going to write the factors of 7, which are 1 and 7. Factors of 20, 1 and 20, 2, 10, 4, 5. And I'm going to group them so that I get, the product needs to subtract to positive 4. So I am going to take 7 times 2 to make 14, 1 times 10 to make 10, subtract those numbers, and I get 4. Therefore, I know 4n squared is the beginning factor. All right. Now, n, which is coming from the 1 here, 7n, which is coming from this 7, and then remember how to partner? We do inside and outside. So, my 1 got partnered with the 10, and I'll show that right here, which means 1n gets partnered with a 10. I see that 7 got partnered with a 2, so 7 has to partner with a 2. I want positive 4. That means the 14n, which is 2 times 7, has to be positive, whereas the 10 has to be negative. Okay? So, should give you the exact same answer. They might be in a different order, though, but they will be the same answer. So that was 10. This one I just put up because just in case you didn't see or recognize that this is the same thing as a squared minus b squared. A minus b times a plus b. In this case, a is equal to x minus 6 and b is equal to 9. Sorry, 3. Oof. All right. So then you just fill in the rule. So x minus 6. I'm going to actually put both your a's first. And then in pink, I'll put my b's. Minus 3 plus 3. So my final answers are x minus 9 and x minus 3. All right, number 49. This one, very similar. I think I actually might have had some typos on the answer key. I'm going to use a different letter than what I used on the answer key because I think I confused myself. I am going to use t. So I'm going to rewrite this as 3t squared minus 36t plus 81, where t is equal to x plus 9. So I'm going to go through and factor this guy, GCF first. And then I get t minus 9, t minus 3. And because the original problem didn't have t's, I got to replace the t's. So what I'm going to do is use the same color for everything else, just so you can see. All I'm going to do is take my t values, which were x plus 9. I'm going to place them right here. So I replace this t with the blue. And then I just simplify. So I believe this was incorrect on the answer key. I think I got myself confused with my A's and 9's. So this one here, 53, was actually a typo. It should have been 8x cubed plus 27. I'm sorry about that. And this is another rule. The rule is a cubed plus b cubed. And that is a plus b times a squared minus ab plus b squared. And yes, you do need to know that. It has to be memorized. So, in this case, how do you know what a is? You're going to literally take the cube root of the first term. So the cube root of 8 is 2. The cube root of x cubed is x. Cube root of 27 is 3. Because this is a plus, that's why we're using this rule that's right here. So all I'm going to do is replace all of my a's with 2x and all my b's with 3. And then be careful here, 2x squared, because a lot of times you'll put 2x squared. And when I said 2x squared, I meant 2x quantity squared, because that's what a squared would be. That would give us 4x squared minus 2x times 3, which is 6x, and then plus 9. This piece will never be factorable. Okay? That quadratic in the back, never factorable. One more here, 55. So this one is another a cubed plus b cubed. A plus b times a squared plus, oh sorry, not plus, minus ab plus b squared. And what do we get? We get a is the cube root of x plus 2 whole thing cubed. So a is actually x squared. B is 5. So following the rule, a plus b times a squared, so that's this piece, squared, plus, wow, do that every time, minus a times b, so I'm actually going to put the 5 first, and then plus b squared, which is 25. And then you just have to clean it up. So we get x plus 7. We get this piece right here will be x squared plus 4x plus 4. And then I'm going to distribute minus 5x minus 10. And then the last bit is the plus 25. Next step, x plus 7 times x squared minus x, and then we have positive 15 plus 4, so plus 19. Positive 15 plus 4, I hope. Hopefully that was correct. Alright. I think that's our last one. What I did put is a link to Khan Academy because they do have more tutorials on different types of factoring. You're welcome to use that if this was way too fast for you, or if you didn't like the two methods that are here. Personally, I don't like any tricks, so I don't like this weird box method that's shown, and then there's a weird one where you can divide by the coefficient. I don't like either of those ways because they're tricks and you have to remember certain things to make them work. All right, enjoy!